Hello, this is Eric. Today we're going to talk about modding a synthesizer. What do you got to do to mod a synth? Well, I study schematics. I look for places that are interesting where you could change a component and affect multiple changes or changes across, say, all six voices, like in the 6-voice synthesizer. So the most interesting things are some of the simplest things. For example, the JX-3P doesn't have a filter control, a real-time performance control for the filter. It seems kind of bizarre. So can we just add one? So if we look at the schematic, we'll see that the filter control voltage hits this multiplexer and then is distributed to 6 different op amps, one for each voice. So basically, the multiplexer is selecting each voice very rapidly in succession, feeding the op amps with the right control voltage signal. It will seem, and it does, be like a continuous signal. Okay. What if I tapped in there? I mean, there's only one place the signal comes in. That's channel 3 on the multiplexer. So if I connected into that part of the circuit, I could change the output dynamically. So what are we going to do? Well, we're going to do some experimenting. First off, I've got a potentiometer. I want to be able to apply a certain resistance to that voltage signal and then reduce that resistance to ground so that that voltage signal will drop. When that voltage signal drops, it's going to be like, turning a filter knob. So we're going to try that. Actually, I'm getting ready to make this even simpler. I'm about to attach this little wire to pin 3. Not on that one. Pin 3 on this multiplexer. That's the input. Then I'm going to connect the potentiometer. And the potentiometer's center tap right now is going to ground. So it's real simple. Very simple mod. Step 1 is complete. I just took a stranded wire, I tinned it, which means I soldered all the little braids together so that it seems like a solid wire. But the purpose of that in this case was just to make sure that I had solder on the wire so that I could just touch it to the pin and heat it up and get just a little melting of the solder to hold it together. This doesn't have to be anything special or permanent, just enough to give me a simple way to try out different potentiometers. So I don't really know what potentiometer I should be using. So that's part of this exploration. I've got some guesses because the voltage signal is pretty low. So it's going to be pretty low resistance. The potentiometer is now in the circuit. So let's see what happens. Cut it out completely. Now there's some filtering there. Hear that? It's kind of nice. I think this is going to work, but as you can tell, I'm making incredibly fine movements on the potentiometer. What that means is I need a lower resistance potentiometer. So this one was 10K it's a B10K, which means it's linear and it's 10 kilo ohms. I think I need like 1K, maybe 500 ohms. Well, after some embarrassing false starts, like the wrong type of strip board, not using the potentiometer right, we've got it rigged up. Right now it's in the circuit. The potentiometer, though, is doing nothing to the sound. This is a nominally 200 ohm potentiometer. It actually reads about 190, which is fine. So we're going to give this a listen as I change it. Now you might think that's just volume. I'm pretty sure it's not. We'll turn up the volume. Play a few more notes. Now, not in the circuit. That is filtering, folks. So I'm reducing the control voltage, going to all the voices through a single potentiometer. Now this one is 200 ohm. You have to turn it a bit before it really starts to do anything. So my hunch is that maybe the adjustable range is 100. By switching to a 100 ohm potentiometer, it gives me finer control. And that's what we really want, right? You don't want to turn the knob and have it jump. So we're going to try the next experiment and put in a 100 ohm resistor, variable resistor. Yeah, that'll be nice. I have switched to a 100 ohm potentiometer. And it does the trick. However, when it's fully open, so it is altering the sound when I don't want it to be. So we need something between 100 and 200. I might need to bias this by like 50 ohms. We'll try that next. I believe I have found a happy medium. That's a 47 ohm resistor. We'll take it out of the circuit. Don't hear any change. So right now it's doing nothing, which is fine. So now we're going to adjust it. Now this is a much more dramatic adjustment to the tone than the other control on the synthesizer has. This has the one control, brilliance. So here we go. C major with brilliance full on. C major with brilliance off. A lot of that change, though, is because of this. So we'll do that again. Brilliance set at the minimum. Brilliance set at the maximum. So yeah, it does make it brighter, but it doesn't really have any cut. You may wonder, well, why is that? Why is it not cutting it out? What is the brilliance control all about? Well, in the schematic here, we see brilliance. There's a gun. This line down here is the output. This is the VCA here. So I'm affecting the CV in, and the brilliance is affecting the CV in. It's just that my little hack is doing so much more. Now imagine being able to adjust that in real time while you're playing. I think this is worthwhile. I have modded this synth, confirming my suspicions that this would be good. I found the values that you need now. 100 ohm potentiometer biased with a 47 ohm resistor. By that I mean the true range across here is basically 47 to 147. So I just shifted the 100 ohm range. I biased it by about 50 ohms. That way I get the maximum effect of changing the signal from the multiplexer to the op amps and into all 6 filters. Happy modding.